Hi there, this is Mar Haddad here again. So in this lecture, I have to continue the explanation, and I'm going to speak about two important protocols that works on the transport layer, which are the TCP and UDP. Before I start speaking about them, let's go to the OSI model, and I have already explained that to you before when I was speaking about the OSI model, that on this layer, the transport layer, there are two important protocols that works, which are the TCP and the UDP. So in this lecture, I'm going to explain to you in details about the TCP and UDP, what are those protocols, what are their function, and how they work. And then I'm going to explain also more in details about especially the TCP, because in TCP, there are a lot of things that you need to know. And this is part of the CCNA curriculum that you should know about it. So the TCP and UDP are part of the CCNA. So let's go back to the slide, and over here I've made a small table here to show you the difference between the TCP and UDP. So as a connection type, TCP is connection oriented while UDP is connectionless. What does it mean? Let's imagine that you are, for example, downloading a file from a web server. So you are using HTTP or HTTPS. Then you are using TCP, because you will see later that the HTTP and HTTPS works on the protocol which is TCP. So that means it's connection oriented. What does it mean? That means that before you start downloading, your computer, which is going to speak to the server, it will do some type of communication with the server to say, hey, I want to start downloading from you, and then it will start downloading. And then in case of any problem that happens on the data which is sent from the server to your computer, then there is a possibility for the data recovery when you use TCP. And also we have to speak later, we will speak about the windowing, we will speak about the sequence. So all of those, we are going to see them in the TCP in this lecture actually. So that's why it's called connection oriented. While UDP, it is connectionless. Why it is connectionless? So I just give you an example here for the VoIP or the video streaming. So let's imagine that you are doing video streaming and something happened to the data. Video streaming works on UDP. So then in this case, in case the video is being received or not, then it doesn't care, because UDP doesn't do any type of recovery. It just sends the traffic, and if it's received or not received, then it's not a problem for UDP. That's why we call it connectionless. So that means it doesn't do any type of recovering for the data. It doesn't check if the data has been received successfully or not. So it's just connectionless. All right. So over here, I also mentioned about the sequencing. So the TCP do sequencing, the UDP doesn't do. What is sequencing? Sequencing means that once, for example, again, we are downloading some large file from the server, and that means the server is sending for us the bytes. So then every time the bytes arrive to my PC, then it will ask him, did you receive it? Then my PC say, yes, I received it. Then he sent him the second part of bytes. Then you receive it, and yes. So that's how the TCP works. It will always check if it has received all the bytes, and also it makes them, put them in order at the end. While on UDP, it doesn't do that. It just sends everything, and if it's received or not, if it comes on order or out of order, that's not a problem. So that's why there is sequencing over here on the TCP, and there is no sequencing on the UDP. Now I just put for you some type of traffic. So we have the download like HTTP and HTTPS, they use TCP, but also more than that. You can think of the telnet as an example. You can think of FTP that works on TCP. You can think of SSH works on TCP. So all of those works on TCP. UDP, you have the VoIP, you have the video streaming. DNS also works on UDP, but also it works on TCP. But or we can say that DNS work on UDP. There is the TFTP works on UDP. So all of those works on the UDP. Now I have made for you here how it looks the header. So I will start with the header of the UDP. You will see that it's very simple. It doesn't have too much of things. You have the 16-bit source port, 16-bit destination port. So those are the ports. The source port means the ports from the source and the destination to where it is going. And you have here the 16-bit UDP length and checksum. So it has very limited checksum. All right, so that means error detection is very, very limited on UDP. And of course, you have this data. So you see, this is a header of UDP. It's very simple. Again, remember, UDP is connectionless. It doesn't do sequencing. It doesn't do the data recovery. It doesn't check if the data arrive in order, and it does a very limited checksum. Okay, so that's something you have to think of UDP. While if we look to the TCP, you can see that it looks much bigger. And I'm going to speak about now the sequence number, the acknowledge number, and the bit which is here, the window size, and the flag. And now you can see we have the source port, the destination port, the sequence number, 32 bits. We have 32 bits, acknowledge number. The window size is 16-bit. We have the checksum, it's 16-bit. And then we have here the data. So those are the most important parts. Now I will stop now and let's speak more about TCP, because TCP is very important. UDP, we know already that it's just send the data. If it's received or not, it doesn't matter. So for him, it's fine. All right. So that's, we call it connectionless, but TCP is connection oriented. So first thing to know about TCP is something we call three-way handshake. Three-way handshake is very important to know about it for the CCNA. What does it mean? Let's think that this is the sender and this is the receiver. All right. So this is the sender and this is the receiver. So my computer, for example, want to send something to someone. All right. So before anything can happen, so let's say it is FTP or it is Telnet or whatever. So there should be some application that works on TCP. So before any data will be sent, there is what we call it the three-way handshake. What does it mean, three-way handshake? That means that first the sender will send here, and this is what we call it the SYN. SYN means synchronization. So he will say, hello, I want to speak to you. Are you available with me? So this is the SYN. All right. Then he will reply to him here. He will say, SYN acknowledge. What does it mean here? This means that he will acknowledge that he has received the SYN which was sent here, and then he will send him this SYN. So what does it mean here? Let's say you want to speak to someone. You say, hello, you are with me? Then he will answer. He say, yeah, I am with you. Are you also with me? All right. So that's what it is. SYN. So hello, are you with me? SYN acknowledge. He will answer, yes, I'm with you. Are you also with me? Then he will say, acknowledge. So he will acknowledge him, say, yes, I'm with you. And here start the data flow. So here the data will start flowing. All right. So that's always for every time you want to open any application which works on TCP, three-way handshake has to start. While on the UDP, you don't have that. So that's one thing to remember and to know about it, which is the three-way handshake. So it is SYN acknowledge, and then he will answer by acknowledge, and then the traffic will start flowing, and then everything will be working. So this is first thing to know on the TCP, which is the three-way handshake. And this is something you see it normally on the flags over here. All right, the SYN and the SYN acknowledge. So that's something you see it on the flag. Now, let's see also what we have in TCP. All right, so we know now about the three-way handshake. The other thing that we can see it over here is, let's have a look, this one, the window size. What does it mean here? Again, we have the sender and we have the receiver. All right. So once the three-way handshake is working, then this is sending. All right, he's sending something to here. So he will make, for example, the window size to be 1. So he's sending, for example, 1 bytes a time. All right, then he will answer him, and he will say 2. That means when he say 2, that means I have received 1. Then he think that, okay, I think I can make my window size bigger. So instead of sending 1 byte, I will send him 3 bytes at a time. So we send 1, 2, 3. All right. So we send him, that means 3, 4, and 5. If he answer him back by 6, that means he knows that he has received. So this is the sender, this is the receiver. He knows that the receiver has received the 3, 4, and 5, and then he will start also sending him, if he window size, he left it 3, he will send him 7, 8, and 9, and so forth. So you see that the TCP is checking every time he's sending something that it has been received at the receiver. In case the receiver answered by, for example, 5, he doesn't answer by 6, so that means this has been missed and he answered by 5, then the sender knows that, oh, this 5 has been missed, then I have to send him back 5 and the 6, and maybe he will make the window smaller. He was making the window equal to 3, now he make it 2. So then he will make it, for example, something like this. He will send 5 and 6, because he knows that he has missed the receiver the byte number 5. So that means there is some conjunction on his link, so he make his window size smaller. All right, so that's very important to know about the window size. So once the receiver, he answer by the number which is higher than what the sender has sent him, then the sender knows that the receiver has received the bytes, and then he will continue working. If the receiver send by a number which is lower than what the sender has sent, then the sender knows that there is a missing byte somewhere, then he will make his window a little bit smaller, and then he will continue sending to the receiver. So you see, the TCP is very reliable. It's a connection-oriented type, and as you can see, it makes first the three-way handshake to be open, and then for everything he sent, he wants to be sure that it has been received, and in case not, then he will send it again. For any error, it will make the error detection. And that's why when you are downloading a file using TCP, that means you're using HTTP or HTTPS, you see that at the end you are receiving the file correctly. All right, so that means in case, for example, you are downloading a file from the TFTP, which use the UDP, in case there is any byte which was not received by the receiver, then in case you make the download for the whole file will not open for you because you have some bytes that are missing, and then you have to redo the download from the beginning. So that's why if you want to do some downloads, I advise you to download files from a web server which uses, for example, HTTPS or HTTP, then you are sure that you are getting the file correctly. So this is what I wanted to show you, the difference between the TCP and the UDP. Here to mention about the ports that you see here, destination port and source port. So those are, for example, if it's going to do FTP on TCP, then it uses the port 21. If it's doing telnet, it uses the port 23. If it's using SSH, it's then it open to the port 22. So these are here the ports. So all the ports are inside the transport layer and inside the TCP header, as you can see here. All right, and now the sequence is when, for example, as I said, when you send the byte number 1, and then he will send him a sequence. He will take a sequence number, for example, sequence number 1. Then if you send back, it will say acknowledge 2, then he knows that he has received the first byte, and then he can send him the second one. And also he put the sequence, and then he will acknowledge by the number which is higher. And that's what I have already explained to you. So this is here on the sequence number. So you can see the sequence number and the acknowledge. The window size is how much you can send the bytes at the same time. And the flags is when we are speaking about the three-way handshake. All right, and at the end you can see here the data is where the data needs to be sent on the TCP, and the checksum, that means that in case there is any error on the data, so it can check it when it's received to the receiver, and in case it find any error, then it will ask to be sent again. So this is what I wanted to show you in this lecture, all about the transport layers, speaking about the TCP and UDP. I hope that this lecture was informative for you, and I will see you in the upcoming lecture.